Hi, welcome to VideoMathLessons.com. Today's a Algebra 2 and Trigonometry lesson. We're going to be talking tonight about exponential functions and how to do the graphs. So let's get started. So first we're going to start off with like a pretty standard function, like like a pretty straightforward one. So why don't we start off with something pretty easy, something like y equals 2 to the x. Now, we know this is an exponential function because there's a variable in the exponent. Now, in class, you probably, hopefully remember that all you're going to have to do is we make a table, and we're going to graph, we're going to plug in values for x and y, or for x, excuse me, and it'll generate the y values. So we started off with 0, and we're going to go down positive, 1, 2, 3, and we go negative, -1, -2, -3. Now, this is a pretty easy one, so I could actually just type this in my, just punch these in and use my brain and just say, well, 2 to the 0 equals 1. 2 to the first equals 2, and so on. But what I want to show you tonight is how to use your graphing calculator. So what we're going to do is turn your calculator on, and what we have to do is we have to input the function. So what we're going to press is right here we say y equals, and we're going to type in 2 to the x. What we're going to type in is actually 2 caret x, 2 to the x power. So here we go, 2 caret x, and the x is underneath the mode button, xt theta n. So we're going to press X, and you have X up on your screen. Now, I could hit graph right now if we wanted to, and my graph is pretty, standard window. If your graph doesn't look like this, your windows are a little messed up, and it depends on what your old graph was or whoever used your calculator was. So what you can do to get your graph to look like this, you press Zoom 6, and that's the standard window. Now, before I need to get this picture onto this graph, so it's kind of small, so what we're going to use is the table. So I'm going to press second table, which is over the graph, and I'm going to look, I want to match my table here, so -3, so I want to go up to where it says -3, and these are my values. Now, before you just start writing things down, let's take a look at these numbers here. 1, 2, then the next number was 4, and 3 is 8. Now, if you look here, -1, they have 0.5, and you're allowed to use 0.5. We talked about in class when you have negative exponents, those are reciprocals. That's why, and what we did was just wrote 1 over 2, 1 over 4, 1 over 8. You could use the decimal equivalents. There's nothing wrong with it. So now what we want to do is take these values and graph them put them on the graph. So now I have an axis. I'm going to label my axes x and y, and we're going to graph these points. I like to start to 0 just to make it nice, a nice place to start. So it's 0, 1, and I'll put some numbers on here so everybody knows what we're counting by. So I'll count by 2's here so it's not so crowded. And some negatives. And I'm going to graph these points. So 1, 2, put a dot. 2, 4, dot. 3, 8, dot. And now the tricky part is going backwards. Now this line here, if hopefully you recall, is called an asymptote. This line is called the asymptote. It's a line we approach but do not touch. So I'm going to do my best. So a half, I can pretty much do a half. Anything less than that gets really a little tricky. So what I want to do is just to make my graph look like it's heading down. And I'm just going to do the best I can. I'll start down here. Okay, and I'm just going to try to draw a nice curve. It's a little tricky with the computer. And I'm just going to go like this, a little bit past, not too far, because at 4, it'd be way up here, all the way up here. So I'm just going to go a little bit past the 3, and I'm going to put an arrowhead on each, and then I'm going to label my graph. Okay, so we always label y equals 2 to the x. Label, label, label. X, y equation. This is an exponential growth problem because this number down here is bigger than 1. Now, sometimes that rule doesn't work because if this variable changes, like with a positive or negative, things can happen. Well, that's our first one. So let's try another problem. So why don't we try something like this? Y equals, we'll keep our 2, but let's do something a little different. 2 times 3, and then up in the exponent, I'll put a negative x. Negative x. Now, normally this number here is greater than 1, so you would think this is a growth problem, exponential growth. This negative, though, is going to change all that. So let's take a look what's going to happen here. So I'll punch in y equals into our calculator. So y equals 2. Now you're going to type it in. This, how you're going to enter it, is going to be like this. 2 times 3 caret negative x. Now, what you could do is you could put the parentheses around the 3, but what I like to do is put the parentheses around this x also. Because the next problem we'll have extra stuff up there. So it's just a good habit. So let's type this in. 2 times parenthesis 3 close caret parenthesis negative x. And let's see what happens. I'm going to hit graph just to get an idea of what's going to happen. And we can see now it's an exponential decay. It's going down. So now this problem, I'm not so, the values are going to be all a little different. So I'm going to rely on my table for this problem. Okay, so as soon as they get a little strange, I'm going to rely on my table. And if you look at these values, they're like way off my screen already. I can probably get 18 on my screen, but I'm not getting 54. And these numbers go really small real quick. So you always make a table. So I'm going to write down a table, x and y. So I'll keep the numbers from -3 up to +3. And so, but I'm not graphing that number, 54. Now, I'm not graphing that number on my scale here. Sometimes the scale will be so large, you will be graphing those numbers. But on these first couple that we're doing, I'm just going to do pretty small. Just a normal counting by ones instead of counting, like each box is worth a 5 or something. So at 0, we're at 2. And this is 0.6. I'm just going to put the bar for repeating. 0.2 repeating. That one's not repeating, so it's 0.074. 07 0.07407, and I'm going to try my best to graph this thing. So like once again, so I got -1, -2, -3, and I'm going to count by ones up here, so that's boxes 2, my values, and I'm just going to graph them. So -354 is off my screen, so I'm not worried about it. -218 is right there. And just graph these. And I'm just going to, head towards that asymptote line right there, the x-axis. So I'm going to do my best to graph this. Let's fix that graph. Come the other way. sides, label, label, label. And that's our graph. Let's try one more. So how about something like this? Y equals 5 times 2 to the 0.25x. Now with this problem, it's important that you put parentheses around these exponents. So why don't you punch this in and see what you get for your table. Okay, so I typed it in, 5 times 2 caret 0.25x, and those parentheses around the 0.25x, and I'm going to hit second table, and there's my values. And remember, once again, we make a chart. From -3 to +3. And this is where, now look, I'm not going to change, I'm writing down whatever is on the screen, I'm writing it down. So 2.973, 3.5355. So copy down your chart. And what we can do is we're going to graph the values. Now, see these numbers, 2.973? Well, that's just about a 3. So when I graph, it'll be -3. So that's 2, that's 3. It's really close to being a 3. You know, it's like way up there. It's like you can't tell it's not a 3, let's say. And 3.535. So graph your points, connect it with a line. If you actually wanted to, you could go up a little bit. You could see that like -4, you know, these values. -5, you're at 2.1. You know, so you're like right around there. So graph your points and then make your graph. Now it looks like a pretty straight line, but actually it is a curve. So what you want to do is be careful and curve it through. And going up. And once again, just do your best. And that's our graph. Oh, that's it. Thank you very much for watching videomathlessons.com, and stay tuned for other videos. Thank you.